Hello there, it's Dave at Fun Science. I hope you're well. This is a video particularly for children who have attended our after-school science clubs in the week beginning 30th of September 2024. I'm making this video because in this week's workshops we are making some painted circuits. Now, a painted circuit is one of these. It is an electrical circuit that is made without the use of any metal wires whatsoever. What it has in place of metal wires is this stuff. Now, this is a sort of suspension of carbon powder in water. Let's call it carbon paint for short. And what children have done is they've got one of these templates and they've painted over the lines, not over the gaps, just over the lines and over a blob here with this special carbon paint. Now, they've added to this painting a little LED and a button cell. And they've made, again from paper and carbon paint, a little switch here. Now, they may have come home with this in a part assembled state because we quite often run out of time and I've only got two hands and I can't always help everybody to finish it off. So this video is for the benefit of parents who want to help children to finish off their circuit. So, a couple of tips to make sure that your circuit is working as it should. Number one, the painted line needs to be thick and continuous all the way around. Not necessarily broad, but it does need to be put on quite thick. If your lines look something like this, you know, they're a little bit blotchy, a little bit thin, not continuous all the way around, maybe you can see the printed line underneath here, that's probably not going to work. So it needs to be nice and thick. Secondly, when you're adding the electrical components, so the LED and the cell, they need to be in contact with the painted line. So if you look here at the LED, you can see its little legs, its little contacts, are overlapping the painted line by a couple of millimeters. And the same is true with the battery. Underneath this coin cell, there is a painted blob, and the battery is stuck onto that blob. Now the battery is stuck positive side down. If you look on the battery on one side, there will be a plus etched into it, and that side needs to go down. That's important because the circuit works when you connect the components one way but not the other way. So your battery is going plus side down. And if you look carefully at the LED here, you'll see that one leg is slightly longer than the other. That's the longer one there. The longer leg of the LED needs to be connected to the wire on the side that the battery is. Flip it round 180 degrees or turn the battery over and this will not work. Do both of those things and it will work. But you get my drift. So we've got the line painted all the way around. It's nice and thick and continuous. We've got the components attached. They're overlapping the black line and they are the right way round. Again, the plus side of the battery is down and the longer leg is towards the battery. Okay? The same with the switch. So the switch is just a piece of paper with some more conductive paint on the back. Now, this is stuck down with a piece of sellotape and importantly, the black paint on the back of the switch is overlapping by a few millimeters the black paint on the piece of paper, right? They must be touching because that's carrying our electrical charge around the circuit. On the other side, when you stick the coin cell down, don't put tape over the whole thing because the tape will break the connection. So again, if you look carefully, there is tape over just over half of the battery and there is no sellotape here, right? So we have a good connection between the negative side, negative terminal of the cell and the painted line here. Stick it all together and what do you get? You get a little LED that glows very, very faintly. Why is it only glowing faintly? Well, that's because of something called electrical resistance, which is another topic for another workshop perhaps. But assemble it all correctly and your little light will come on when the switch contacts the battery. Now, if you've got home and found that your lines aren't dense enough, aren't thick enough to carry an electrical current all the way around, never fear. You have two options. Number one, you could go online and you could get yourself some of this stuff. It's fairly expensive, but you can get it in little tubes for a few pounds. It's called liquidy wire. That's like liquid, but knock off the D and replace it with wire. Liquidy wire. Alternatively, you could find something else which is going to conduct your electrical charge. So something small and metal, a piece of wire, a paperclip, a staple, some tin foil. Those are all things that you could use to bridge any gaps in your circuit. So if your child has attended one of our after-school clubs this week and made one of these, now you know how to make it work. If your child hasn't attended a fun science after-school club, and made one of these, this is what you need. A piece of paper, sticky tape, scissors, LED, coin cell, this is a 3-volt CR2025, paper, paint, LED, cell, scissors, paintbrush, or a cotton bud works very well. And that's it. You can find all those things on Amazon and probably on eBay as well. I hope this was helpful. I hope you have fun with your painted circuit, and I hope to see your child again very soon at one of our after-school clubs or workshops. One final thing, if they have got any of this stuff on their clothes, it does wash out. I've washed it out of my lab coat plenty of times. Just use lots of warm soapy water. Okay? See you next time. Bye.